Alright, for this one you have vertical angles, supplementary angles, and properties of angles. So for the first one here, we want to find the measure of each angle marked below. So here for part A, we have a 5x minus 3 and a 3x plus 5. And you'll notice that they are across from each other. These are what are called vertical angles. So for vertical angles, we actually have that those two angles are equal to each other. So to solve for what those are, we want to set the 5x minus 3 equal to the 3x plus 5. And then we want to go through and solve for x first of all. So you can go through and solve like normal. So one way to do that is to subtract the 3x on both sides to get the x's together. So then we'd have 2x minus 3 equals 5. And then we can add 3 to both sides to get our x part by itself. So then we'd have 2x equals 8. And then finish off solving for x by dividing both sides by 2. So for this first one, we get x equals 4. But don't stop once you get what x equals, because we need to figure out the measure of the angles. So that means we need to actually plug back in our x value to figure out what those angles are. It doesn't matter which one you plug it into because they're both equal to each other. So here, for instance, if we do 5 times the 4 minus 3, make sure to use your order of operations like normal. Multiply first and then subtract the 3. So we'd have a 20 minus 3, which gives us 17. So our angle here is 17 degrees for both of those. So that's for part A. For part B, you'll notice it's a little bit different because this time we have the angles side by side and they are along a straight line. So these ones are the second case here, the supplemental angles. So supplementary angles add up to 180 degrees. So here in this case, we'd have our 2x plus, and then add together our other angle, the 3x plus 5, and then set that equal to 180. Supplementary angles have to add up to 180 degrees. Separate these two problems here for you. So then combine like terms, we'd have 5x plus 5 equals 180, and then subtract the 5 from both sides to get the x part by itself. So we have 5x equals 175, and then finish getting your x by itself by dividing both sides by 5. So here in this case, we get x equals 35. Once again, do not stop once you get what x is equal to, because we want what the angle is. So here we want to figure out both of those in this case because they're not equal here. So we'd have the 2 times 35 for the left angle here. So we get 70 degrees. And then since these have to add up to 180, that means this other one here should be 110 degrees. And you can go through and double check that by plugging back in your x value. Make sure that you get 110 there as well. So those are vertical and supplemental angles. For some properties of angles, we have number 2. Use the properties of angles to find the measure of the angles that are marked below. So here in this case, these are what are called corresponding angles. And corresponding angles, like vertical angles, are equal to each other. So kind of like we did in part A, we're going to set those two equal to each other. The 2x plus 4 equals the 3x minus 7. And then we'll go through and solve for x once again. So here this time I'm going to subtract the 2x so that way we can try and keep the x's positive. So then we have 4 equals our x minus 7. And then we can add 7 to both sides of the equation to finish getting x by itself. So we get 11 as our x value here. Once again, do not stop once you get the x. We need the angle measures. So we have 2 times 11 plus 4 if we plug it in for this top angle here. So then we get 26 degrees. And just like in part A, once we have one angle, we have them both because they are equal to each other since they are corresponding angles. And remember, corresponding angles are whenever you have two parallel lines, the transversal, and they're on the same side of that line, but not right side by side. If you have questions, make sure to ask like normal.